right, this is the quick discussion on delocalized pi bonding, that topic in bonding that we're not going to actually discuss in class, but you still need to realize what it is. This is going to be a fairly brief one. Delocalized pi bonding. Before I go show anything in terms of notes, think about what the word delocalized is saying. If something is localized, it means that it's focused in one small area. Right, a localized outbreak of swine flu means that, okay, swine flu is just happening in this one small place and it isn't widespread. Delocalized, on the other hand, means that it's spread out. It's spread out over many locations. So delocalized pi bonding is saying that, oh, all it's saying is, okay, you've got pi bonding in multiple locations. And pi bonding, recall, well, hopefully you have at least read a little bit about pi bonding prior to watching this, or you've seen the sigma versus pi bonding. Pi bonds are the bonds that make a double bond a double bond. A double bond is one sigma and one pi. A triple bond is one sigma and two pi. So when we're talking about pi bonding, we're talking about multiple bonds. And delocalized pi bonding means that we've got multiple bonds in different locations. Oh gosh, multiple bonds in different locations. That sounds an awful lot like resonance structures. And this is precisely what delocalized pi bonding is. It's essentially a way to describe this thing with resonance structures about the double bond being in different possible locations, right? Delocalized pi bonding, your pi bond is spread out over multiple locations because your double or your triple bond, you can draw it in different locations in your Lewis structure. So delocalized pi bonding is something that goes along with resonance structures because you're simply saying your pi bond, your double bond, your triple bond isn't pinned down to just one place. Benzene, the 6-carbon-carbon ring structure with alternating double bonds. In benzene, there are 6 carbon-carbon sigma bonds. And remember, sigma is single. The first bond that you form between two atoms will always be a sigma bond. And there are also 6 carbon to hydrogen sigma bonds. Because the carbon in benzene is sp2 hybridized, there's one unhybridized p orbital left on each carbon. So there are 6 unhybridized p orbitals total on the ring. Basically, each carbon in benzene, because benzene, right, our 6-carbon ring, looks like that. And then it's alternating. I'm going to leave off the H's, but these are all the H's. It's alternating single and double bonds. Each one of those carbons, if you look at it, it's got 3 electron domains, because remember, double bonds count as just 1 electron domain. So 3 electron domains means sp2 hybridized, because it means that you need 3 places to put your electrons. So the carbon takes an s and 2 p's, and it blends them all together, hybridizes those orbitals. We get sp2 hybridized orbitals, but there's still a p orbital left, and there's a p orbital left on every single carbon, because you look at this carbon ring, every single carbon has 3 electron domains. Every single carbon is sp2 hybridized. So unhybridized p orbital left over on every single carbon. And that's where the delocalized pi bond comes. 2 options for 3 pi bonds, meaning 2 resonance structures. You can have resonance structures where, you've got the double bond in one location, and then you switch all the double bonds, you kind of shift them all to the different location. Delocalized pi bonding simply means that your pi bonding is spread out over the entire benzene ring. That's all it means. The pi electrons that are involved in the p orbitals that are involved in that pi bonding, they wind up being shared by all of the carbon atoms. And that structure there comes from the 6-chain ring in benzene. It comes from what happens when you take each of these leftover p orbitals and the top half are all connected. Well, basically, you're going to keep on shifting with your resonance structures, whether the double bond is in one location or a second location, and then the bottom are all connected. So we get kind of this donut-looking thing. What do you need to know about delocalized pi bonding? You need to understand what the phrase means, that the phrase is something that goes along with resonance structures, that it means that your double bond or your triple bond can be spread out over more than one location. Questions that I've seen asked in the AP about delocalized pi bonding, they will simply ask you, which of these compounds would you expect to exhibit delocalized pi bonding? Look for the compound that has a resonance structure. Guarantee you there's only going to be one of them. You can have a pi bond and it doesn't have to be delocalized. It can be pinned down to one location. This would be in the case of a Lewis structure that doesn't have any resonance structures. You can have a double bond in the Lewis structure and not have any place else to put it. Maybe everything else with hydrogens and you can't make the double bonds with hydrogens. So if the question says, which of these molecules would you expect to exhibit delocalized pi bonding? Look for the one with the resonance structure, because the one with the resonance structure, that pi bond won't be pinned down to one location. It can exist over multiple locations. So hence the pi bond will be delocalized.